So, hello. So, once again, we will be starting now with the process dynamics and control. In the previous lectures, we have seen how process dynamics and control is useful, what is the need of process dynamics and control, and we have seen the mathematical tool known as Laplace transform as a concept which is used for solving various process dynamic control related issues and problems. So we have seen the properties of Laplace transforms, how to solve the differential equations using Laplace transforms, what are Laplace transforms, and what is transfer function. Transfer function is nothing but the ratio of output response to that of input response in Laplace domain, generally known as transfer function. So that transfer function we have derived for first order system. Then we have derived for various examples in first order, that is mercury thermometer, liquid level system, liquid level with constant flow rate, heating process, mixing process, and we have solved some problems related to that in the first unit. So now we will be starting with the second unit, which is nothing but in which we will be discussing about response of second order system. Here first topic, response of second order system, where we will be considering a U-tube manometer as a second order system. So U-tube manometer is considered as the second order system. Okay, initially let the mercury level be the same on both the arms. Initially let it be both the mercury levels be same on the both of the arms. After the process starts or after the process begins, there is a force developed or forces applied on the pressures are applied. This is especially these examples you see in your FM lab, where venturi meter, orifice meter, pipe fittings, V notch, Reynolds experiment. Wherever you have seen this, you have wherever in the equipment itself you have a U-tube manometer which is connected to observe the pressure reading. So you calculate the heights. Generally they are known as head. You calculate the height of the mercury, right? Generally we take it as head. Okay. So that is the case. After the process begins, so what happens in the labs? What do? You will pass water, so that mercury level in one of the arm decreases, one of the arm increases due to the applied pressures, isn't it? So the same process, let us take example. Initially the mercury levels are same, then after the process begins, mercury level decreases. Mercury level decreases in one arm and in other arm it increases. Let the complete process, the head change, the total change in the height, you take it as h. The total change in the height or the total change in the head during the process will consider as h. The increase in this arm will be considering as h by 2. The increase of the mercury level in the left arm or in the right arm is h by 2. So as there is an increase of h by 2 in this layer, obviously the mercury in the other side decreases due to the applied pressure, which is also h by 2. If h by 2 is increasing from this side, h by 2 will decrease from the other side, isn't it? So this is the situation. A U-tube manometer, initially you have a mercury at the same levels in both the arms. So when you are performing the experiments in your FM labs, which is your U-tube, venturi meter, orifice, or any other labs, wherever you have considering U-tubes, you generally consider for the measurement of pressure heads. So here, as the process is beginning, there will be the changes you can see in the mercury levels, which is h by 2. If the total change you take it as h, and if h by 2 amount of increase is there observed in the right arm, then there would be a decrease of h by 2 in the left arm. So this is our situation. So now here there are various frictional forces that is developed between the walls and the fluid. That is the walls and the fluid, and also the mercury. Due to this mercury and due to this fluid, there will be a frictional force that will be developed due to the wall of this U-tube manometer. Okay, and there are pressure forces also acting. So there are various forces acting on this YouTube manometer. So here for calculations for second order system, we generally go for momentum balance equation. We generally go for momentum balance. So momentum balance is nothing but rate of momentum is equal to, we'll calculate the rate of change of momentum in this actually. Okay, so that is rate of change of momentum is equal to unbalanced force or sum of forces acting on the system for the fluid to flow. For the fluid to flow, whatever the forces are acting on the system, sum of all those forces will give you rate of change of momentum. Right? So these forces are generally pressure forces. Okay. So these are unbalanced pressure forces minus the frictional force. Why we are subtracting the frictional force is because in this YouTube manometer you see here, due to this walls there will be developed a friction, right? That friction will oppose the motion of the fluid flow, because whenever this fluid is flowing, it hits the walls of this YouTube manometer. So what happens? This will obstruct the flow. When you throw a ball, for example, in a room in zigzag direction, when it hits the other wall and other wall, what happens? The speed goes on decreasing. So that is opposing the motion. So in the same way, it is opposing the motion, right? So that opposing motion you have to delete. You have to subtract those opposing motion, because we only want the system, the forces that are allowing the fluid to flow. But this force is reducing the flow, or mean it is opposing the flow. Okay. So first we have to calculate the unbalanced forces. First calculation of unbalanced forces or unbalanced pressure forces. Right. So in this YouTube manometer, what are the pressure forces acting? So first of all, what is force? Pressure. Force into, force per unit area is pressure, right? Force per unit area is given as pressure. So what is the force? Pressure force, or what is the pressure force? Pressure into area, isn't it? Pressure is equal to force per unit area. So what will be the force? Pressure into area, isn't it? So now what is the pressure that is developed due to this P1? It is P1 pressure into area pi r square or pi d square by 4. R square, R can be written as d by 2. Okay, pi d square by 4 minus P2 into again pi d square by 4. Why minus? Because these portions are acting in opposite directions. This pressure force that is developed in opposite direction. If one is increasing, the other is if one side if it is increasing, the other side it is reducing. So the pressure is acting in opposite directions. So hence you will consider minus P2. Minus, now there is a pressure also developed because of the fluid that is present. The pressure developed by the fluid that is present. This is your pressure normal that you are applying. But due to that pressure, due to the fluid also some pressure will be exerted, right? In this you have a fluid. That fluid also will develop a pressure, which is rho g h. Rho g h into again area pi d square by 4. Again, why are you subtracting this pressure? Because this pressure is opposing the flow. This pressure will oppose the flow. Hence you subtract it. Okay. So therefore the total pressure is P1 minus P2 minus rho g h into pi d square by 4 is the total unbalanced forces. Is the total unbalanced forces, pressure forces. Is it clear how to calculate pressure? Pressure is force per unit area. So the force will be pressure into area. So first, due to P1, pressure is P1, area pi d square by 4 minus P2. Why P2? Because the force is developed in opposite directions. The one force is decreasing and the other force is allowing to rise. So the forces are acting in opposite directions. So hence you subtract. Now even the fluid that is present in the manometer will develop some pressure, which is rho GH. It is rho GH into area. Why again you are subtracting? Because this will oppose the motion of the flow. Hence you will subtract it. So P1 minus P2 minus rho GH into pi d square by 4. This is your unbalanced pressure forces. Now you have to calculate friction force. Now calculation of friction force. So what is the pressure force that you got? Pressure force is implies P1 minus P2 minus rho GH into pi d square by 4. This is your pressure force. Now, what is stress? What is shear stress? From fluid mechanics. Shear stress is always equal to frictional force per unit area. Shear stress from fluid mechanics, shear stress is equal to frictional force per unit area. You already know this. So therefore, what is the frictional force? Frictional force is equal to shear stress into area. This area will be the area of cross section. Area of cross section, that means this is, if at all you are calculating frictional force in this area, then you will only consider this part, length into breadth. Length into breadth. The length into breadth. So area of cross section you will consider here. Okay? So cross sectional area you will consider in this case. So therefore, shear stress, you take the stress as tau wall into pi d L, diameter into the length of the cross sectional area you will consider. Okay, so this wall, why you have taken stress of the wall, stress wall? Because generally the stress or the frictional force is developed because of these walls. So the stress is also developed on these walls. Now from Huygens-Poiseuille equation, which you have already derived in your fluid mechanics, Huygens-Poiseuille equation, we have shear stress is equal to 8 mu V bar by D. 8 mu V bar by D. So substituting this here, 8 mu V bar by D into pi dl. So this D and D gets cancelled. So 8 mu V bar pi L. 8 mu V bar pi L. So this is the frictional force. But this is the frictional force. But what is the average velocity? Distance travelled by time. Average velocity can be taken as distance travelled by time. So in the figure you can see it is travelling a distance of how much? How much height is it travelling? H by 2. The mercury change is how much? H by 2. So dH by 2 by dt. So therefore V bar is written as 1 by 2 of dH by dt. Substituting this V bar equation in this equation, you get 8 into mu into pi into L into V bar is 1 by 2 dH by dt. So these 2's are, 4's are, finally you get 4 mu pi L dH by dt. 4 mu pi L dH by dt. Is it clear? 4 mu pi L dH by dt. So therefore this is your frictional force. So frictional force is equal to 4 mu pi L dH by 4 mu pi L dH by dt. So now you calculated your unbalanced forces, then you calculated your frictional forces, which is 4 pi mu L dH by dt. You calculated this. Now you have to calculate rate of momentum. Rate of momentum is equal to, what is momentum? Mass into rate. So change. Rate is obviously inflates d by dt. Momentum is nothing but mass into velocity. Mass into velocity. But if there is some error developed in the, if there is some error in the YouTube manometer, that correction factor also should be included. So momentum correction factor. Momentum correction factor. So therefore d by dt of mass can be written as density into volume. Volume can be written as area into area into length. Area into length, right? Density, area into length. Area is again pi by 4 d square into L. Is this clear? Mass is equal to density into volume. A volume can be written as area into length. So rho into, what is area? Pi by 4 d square. So therefore d by dt of mass you substitute here. Pi by 4 d square, rho pi by 4 d square L. Rho pi by 4 d square into L is the mass. Into velocity we already calculated. dH by 2, 1 by 2 of dH by dt. 1 by 2 of dH by dt. Or instead of that, let us take, instead of, to avoid that confusion, we will take directly simplification of that. Yeah, d by dt into v bar, that is the velocity, into momentum correction factor beta. I'll tell you how to substitute that v bar. Velocity is v bar, we already calculated, I know. Momentum correction factor, let us assume that to be beta. Okay, now only the parameter that is changing is velocity. The only parameter that is changing is what? Velocity. So remaining terms can be taken common. So rho pi by 4 d square L into beta into dv bar by dt. Into dv bar by dt. But d into d by dt of, what is v bar? We already calculated in previous in your frictional forces we already calculated. dH by 2 by dt. So 1 by 2 of dH by dt. So this can be written as rho into pi d square L beta by 4 to the 8 into d square h by dt square. Rho pi d square L beta by 8 into d square h by dt square. D square h by dt square. Is that clear? Is that clear everyone? Rate of momentum. So therefore rate of momentum is equal to pi rho pi d square L beta by 8 into d square h by dt square. So this is what is your rate of momentum. Now what is the equation? Rate of momentum is equal to unbalanced pressure forces minus frictional forces. So substitute. So rho Now you will write this equation for unsteady state first. Unsteady state. Rho pi d square L beta by 8 into d square h by dt square is equal to unbalanced forces. P1 minus P2 minus rho g h into pi d square by 4. Pi d square by 4 minus 4 pi mu into L dh by mu into L dh by dt. You can take pi common throughout and get pi you can cancel. Right? Can you cancel pi? Okay. So now this is the equation. Now considering the float and whatever you have in this YouTube manometer, the mercury flow or the fluid flow will be laminar. Yes, it is laminar flow. So for laminar flow, from your fluid mechanics, for laminar flow, the momentum correction factor beta is always given as 4 by 3. The momentum correction factor is given as 4 by 3. So for laminar flow, beta is equal to 4 by 3. So substitute here 4 by 3. So 4 2's. So you have rho d square L by 6 into d square h by dt square is equal to P1 minus P2 minus rho g h into d square by 4 minus 4 mu L dh by dt. dh by dt. Take here. Now taking 4 LCM here. D square minus 16 mu L dh by dt. I am taking LCM here 4. So if I take this will become by 4 and I take the 4 the other side. So rho d square L into 4 by 6 d square h by dt square. So those are 3. So rho d square 2 by 3 of rho d square L by L d square h by dt square is equal to P1 minus P2 into rho g h into d square minus 16 mu L dh by dh by okay. Now this can further be written as 2 by 3 rho d square L d square h by dt square is equal to P1 minus P2 can be taken as delta P minus delta P d square minus rho g h into d square minus 16 mu L dh by dt. Now dividing the factor by rho g d square. Dividing it by rho g d square. Rho g d square. Divide the factor by rho g d square. Divide the above equation with rho g d square. So 2 by 3 to rho d square L by rho g d square. So d square cancel, rho gets cancelled. So you have L by g. L by g. into d square h by dt square is equal to delta p by rho g. Delta p into d square by rho g d square. So d square gets cancelled. So delta p by rho g minus rho g d square. So remaining will be h minus 16 mu l by rho g d square into dh by dt. dh by dt. Now let us consider 2 by 3 L by G as tau square. 2 by 3 2 L by 3G as tau square. So tau square d square h by dt square is equal to this delta p by rho g will take some function x. We'll take it as a function x minus h as usual minus you have taken tau as 2L by 3G. So 2L by 3G you have taken as tau square. So therefore you can take 2 zeta. Now you take this complete term as 2 zeta tau. 2 zeta tau. 2 zeta tau. 2 into zeta, not mu. We'll take this term as 2 zeta tau. We'll take this term as x, some function x. H is as it is. 2 by 2L by 3G will take it as tau square. And this 2 into zeta tau dh by dt. Now taking this 2 zeta tau on other side and this h also this side. So tau square d square h by dt plus 2 zeta tau dh by dt minus plus h is equal to the function x. Function x. So this is your complete equation for unsteady state. After that, the equation for steady state you write tau square d square hs by dt square plus 2 zeta tau dhs by dt plus hs is equal to this factor is constant. This factor is constant. This factor will not change. P1 minus P2 will remain same whether it is in steady state or in final unsteady state. This is a constant factor. So that is also function x, steady state. So now subtracting unsteady state minus steady state as usual. You have in steady state it is taken as x's. I am so sorry. Pressure will change, no? I'm so sorry. Yeah. So pressure also changes. Now, when you are applying the steady state and unsteady state, when you subtract this tau square common, h minus hs will consider at let us consider h minus hs as some capital function y. Capital function y. Some capital function y. So here d square h minus hs by dt square. So d capital Y by d square capital Y by dt square. 2 mu zeta tau. 2 zeta tau. dh minus hs. H minus hs. Again it is d capital Y by dt plus h minus hs plus capital Y. X minus xs. You consider x minus xs as capital X. This x minus xs you consider as capital X. X minus xs as capital X. Now apply Laplace transform to this function. Tau square. Laplace transform if you apply, What is second order? S square y of s minus s into y of 0 minus y dash of 0 plus 2 zeta tau s into x of y of s minus y of 0 plus Laplace transform of y of s, Laplace transform of x of s, isn't it? Now y of 0 is what? Y naught minus ys. Capital Y is y minus ys, right? So y of 0 will be y naught minus ys, the initial height. Oh sorry, h minus hs. Sorry, h minus hs. H naught minus hs. Initial height and the steady state height will be the same, because you will wait always to begin the calculations when the system reaches the steady state. So initial value, your h naught and hs will be the same. So henceforth y of 0 will be 0. As y of 0 is 0, y dash of 0 also becomes 0. Y of 0 is 0, so y dash of 0 also becomes 0. So this terms gets cancelled. So the remaining terms, you have tau square s square y of s plus 2 zeta tau into s into y of s plus y of s is equal to x of s. Taking y of s common, tau square s square plus 2 zeta tau s plus 1 is equal to x of s. So therefore y of s by x of s is equal to 1 by tau square s square plus 2 zeta tau s plus 1. So this is your transfer function for any second order type system. Any system, not only YouTube manometer, any system. That's what we took general y and a. Instead of h minus hs, we took it as y. So if we take h again, you have to derive for various cases. There you had difference for in all the cases. But here second order system, this is the general standard expression. Y of s by x of s is equal to 1 by tau square s square plus 2 zeta tau s plus 1. So first thing in this is you consider a YouTube manometer, where you will have initial heights of mercury as same. As the process begins, the change in complete height you take it as h, and if the rise in one of the arm is h by 2, there will be a decrease in the other arm of h by 2. Okay, so now to calculate transfer function of this kind of second order system, we will consider momentum balance equation. So we have to calculate the rate of change of momentum. That rate of change of momentum is generally the sum of forces that is allowing the fluid to flow. That forces are equal to unbalanced